Okay, for this problem, let's take a look at it. We have a manufacturer can produce X fittings per day where the number of fittings should be in between 0 and 10,000. Production costs are $1,000 per day for the workers. So let's create a formula to figure out how much everything is per day. So at the beginning, for sure, it's $1,000 per day, so we need 1,000 here, okay? So that's the first bit that we have here. Next, it says it's €2 per day per fitting. So this is also per day, all right? And so we need to figure out, well, what does that mean? It means that we have €2, and then how many fittings do we create? Well, we create X fittings, all right? So they tell you it's per day so that we know that all of this works together. So everything has to be in a per day basis. So $1,000 per day, 2 times the number of fittings per day, and finally we have 5,000 over X euros per day for running costs. So we add this as well, and we have 5,000 over X, and that is our total costs for creating these fittings per day. If we look at the question, it says how many fittings should be produced daily to minimize costs. So of course, if you want, you can graph this and figure this out quite easily, but they probably want you to use some calculus. So let's see, hold on a second. If that's the case, whenever we want to minimize something here, that means that your derivative, f of x, it should equal to 0, and you have to solve for that. So this is my cost function. So I have c of x is equal to what I have here. So 1,000 plus 2x plus 5,000. And I'm going to bring this x up here. All right, so I have x to the minus 1. So I've cleaned up my cost function, so I'm ready to derive. So now we want to find c prime, which is the derivative of this cost function with respect to x. So if that's the case, 1,000 goes to 0, because if you derive a constant, you get 0. If you derive 2x, you should just get 2. And if you derive 5,000 x to the minus 1, you bring the the minus 1 to the front to times by 5,000. So 5,000 times minus 1 is minus 5,000. And we have to subtract 1 off the exponent, so we have x to the minus 2. So this is our derivative function, okay? And now what we need to do is, like I pointed out before, we want to take our derivative and equate it to 0. So if we do that, we have 0 is equal to 2 minus 5,000 x to the minus 2. All right? And actually what I can do, it's much easier to do algebra if we take this x from this piece here and we move the x back underneath so that it becomes x squared. So if I do that, I actually have over x squared. All right? Now, of course, you can put this into your calculator. That's the easiest way. So this will give you your method mark. So here you get your method mark. But if you want to do algebra, we can do algebra together. In your calculator, normally you would plot this as y1, plot this as y2, and find the crossing point. And that would be your x that gives you a minimum. But we can do algebra for those who want to do that. So what I would do is I would rainbow this 2 onto the other side. So let's go here. And I have, that becomes negative, so I have negative 2 is equal to minus 5,000 over x squared. Now I'm going to move this x squared up and across. So it's going to go up and across here. So I have minus 2 x squared is equal to minus 5,000. And then, let's see, hold on a second as I move my window. Okay, so we go. And then I'm going to now divide both sides by -2. That cancels out, so I get x squared is equal to minus 5,000, or negative 5,000 divided by -2 is 2,500. And now we take the square root of each side. And we take the square root, we have x is equal to, if you do the square root of 2,500, you should get 50. And I believe that's the answer in the textbook.